Okay, YouTube, this is my 8th and final video on my module on logarithms, but we're going to talk about the domains of logarithmic functions. Very easy to determine the domain of a log function, and I'll tell you why. Okay, so recall that y equals log base a of x is only defined for bases that are greater than 0. In other words, if I rewrite, log base a of x is equal to y as an exponential expression, I get a to the y equals x. We're saying let's keep our bases positive. Imagine if you had a negative base to the power of y. Well, every time y is even, you'd get a positive output, and every time y is odd, like a negative base to an odd power, you get a negative output. So we restrict our a values being positive, okay? But also this, we say also x is positive. Another way to look at this is if a is positive, if I'm taking a to any power, y, then I'm saying I'm always going to get a positive output. Okay, so what this means is also this, in a logarithmic expression, we say this must also be positive, like always. Always it has to be positive. So it wouldn't be defined for any x values that are negative, okay? And recall when we're talking about domain, we're referring to x values here, okay? So we say in order to find the domain of logarithmic functions, we just want to find all the values of x such that x is like positive. And I shouldn't be using x here, I should be using this expression. So we say find the domain of these following functions. I'll just make it really easy for everybody. We'll just take a look at these down here. But what I'm saying is this right here, whatever's in here, must be positive, okay? So what I want to do is I want to go find all the values of x for which this expression right here is negative. So in order to find the domain of this function, here's what you do. You just take what you are taking the log of, and you set that expression to less than 0. Actually, let's do you a solid here. Let's just go the easier route. We say greater than 0. I want to know what are all the x values that cause this to be greater than 0. Because those are the ones that would cause this function to be defined. So solving this, we say negative 3. We get this, x is greater than 0. Oh, did I really just do that? Greater than negative 3. So we'd say the domain of this first function here is this. We say all reals such that x is greater than 3. Because those would be all the x values that when I plug them in, I would get something that is positive. Not even 0. I don't even want 0. I just want greater than 0. So we'd say positive, okay? Real quick, if we were to look at the graph of this, by the way, before we move on to the next one here, you would necessarily notice this. If I said go graph y equals ln of x plus 3, you know what we'd do first, if I said sketch this, what we'd necessarily do is we just go draw the parent function, y equals ln of x. And what do we know about logarithmic graphs? Well, we should know, I hope at this point, that there's a vertical asymptote, vertical asymptote on the y-axis at x equals 0. It goes through the point 1, 0, and since the base is e, then we say if I said log base e of an x value, e, we get 1, okay? So if I were to go out to e, it's 2.718, I would be at a height of 1, essentially. So we say here's our graph, this is our parent function. This function is just the original, we say shifted left 3. Our h value is left 3, so we say shift left 3, 1, 2, 3. And we now have a vertical asymptote at x equals negative 3. So you could see easily, if I shift everybody left 3, so instead of 1, 0, I'd be at negative 2, 0. Instead of 2.718, 1, I'd be at 1.718, 0.718, negative, 0.3, whatever. We'd have my graph here. But you can see that the domain of this function with your eyes now is everything, past negative 3. To the right of negative 3 is where the defined domain is, okay? But the easy way, again, is just this. Take what's inside your log here, set it greater than 0, and solve. This one here. Take a look at it. We'd say, well, what's the domain of this? Well, we say I want all x values that cause this statement to be true, for this thing to be positive. That's what I want. And so we'd say solving this, we get negative x is greater than negative 3. The important thing, and I wanted to do this example on purpose, is because if I divide out a negative 1, recall that in an inequality you need to flip your sign over. So we say all x values less than 3. So we'd say domain. We just write all reals such that x is less than 3. Okay? And then this last one here, we say, all right, well, what could I plug in here? All x values that would cause this to be positive. Okay, so we say x cubed, I just need for this expression on the inside of here to be greater than 0. So we say solving this, we take the cube root of both sides, cube root, and so we'd say x is greater than the cube root of 0, which is 0. but basically all positive x values, okay? And so we could graph these easily and take a look at them. Ln of 3 minus x, just real quick. I mean, the video's done essentially. You could turn it off, but we say, just to get a look at this, ln of 3 minus x is what this looks like here. Basically, when we said 3 minus x, that's the same thing as, let me scribble this down for us here. We talk about the translation here. The parent function would be ln of x. But what you can see here is this. We've got a negative x on this transformed function. So negative x caused this to reflect about the y-axis. And we have a positive 3 in here. You'd say it shift left 3. I want to point this out. We say this is the same thing as if I factor out the negative out front. We'd get this x minus 3. You can redistribute this and see that I get the same thing as what I have written here. But I have a negative plugged in front of my x, so it reflects about the y-axis, and it shifts right 3. So here's what we have. Shifted right 3. It reflected, first of all, would have gone through 1, 0, and it goes through 0, 1, and open this way, and then shift 1, 2, 3, right 3. Okay. But basically, you could see this, all x values that were less than 3, which is what we expressed here. Was our domain. And if I were to graph the ln of x cubed, which is, I don't even know what that looks like. Let's just take a look. Ln x power 3, graph it. There it is, but you can see that it's defined for all x values that are positive, and that is essentially what we listed here. So what's the moral of the story? If you want to find the domain of a logarithmic function without graphing it, just take the inside here, what you're taking the log of, set it greater than 0, and solve for x. That is your domain.